Hi, I'm Caitlin from Sci Enza at the University of Pretoria, and today we'll be discussing states of matter. This table, this bottle, even this scale, we're all made of matter. Even your dog named Fluffy and the air we breathe is made of matter. But what exactly is matter? Well, you see, matter is defined to be anything that has mass and takes up volume or space. But if everything's made of matter, then why is everything so different? Well, you see, there's this thing called properties, and everything has different properties. How heavy or light it is, how hard it is, even how cold it is. These are all properties of matter. And one of the important properties of matter is the state of matter. There are three primary states of matter in the universe: solids, liquids, and gases. Solids are things like rocks and scales and tables and even ice cubes. Solids are anything that can keep their own shape. So they have to have mass and they have to have volume. So let's test that. If we take ice cubes and we put it in a scale, like this, then the scale tips, which means it has weight or mass. And it's also taking up space inside of the container, which means it has volume too. So it has mass, it has volume, it must be made of matter. Now, what makes solids different is that they can keep their own shape, and they only change shape if you force them to. Next, we move on to liquids. Now, liquids can flow. Liquids are things like milk, juice, and water. So, once again, they have to have mass and they have to have volume. So what we do to prove this is we take some liquid. Here we have water with a little bit of blue food coloring in it. When we take the liquid and we pour it into a glass, the glass gets heavier and the bottle gets lighter, which means that the liquid has mass. And it's also taking up space in the glass, which means it has volume too. So liquids have mass and they have volume, so they must be made of matter. But what makes them different is that they flow. So they can take on the shape of their container, leaving no gaps. Now we move on to the trickiest state of matter: gas. The problem with gas is that most gas, like air and oxygen and carbon dioxide, the gas we breathe out, they're all invisible. So if they're invisible, how do we know that they have mass and they have volume? Well, let's go back to the scale. If we take two balloons, completely empty, and we put them on a scale, the scale will balance. But if we remove one of the balloons and we replace it with a balloon that has air in it, then the scale tips, which means that the air must have mass. And the air has volume because it's what makes the balloon expand. So, gas has mass and it has volume, which means it's also made of matter. But what makes gas super cool is that gas can expand, which means that it doesn't just fill up a little bit of the volume, but it fills up the whole volume. So solids can keep their own shape, which means that they have a constant shape and a constant volume. Liquids can flow, so they have a changing shape but a constant volume. And gases, which can technically also flow, have a changing shape and a changing volume. Just because something starts off as one state, though, doesn't mean it's going to stay that way. When we have solids, we can turn them into liquids by melting them. If we have liquids, we can turn them into solids by freezing them. We do this all the time. That's how we get ice cubes. We take water and we put it into little containers and we put it in a freezer to cool it down, and then they solidify and turn into a solid. So, there's another neat little trick that I can show you. Just like liquids can turn into solids and solids into liquids, liquids can also turn into gases. When we boil kettles, we heat up a liquid until it vaporizes and turns into water vapor, which is a gas. But we have to be very careful because steam or water vapor can be very, very hot. So we should never touch it because it can burn us. So, when the water has heated up, it will turn into water vapor, which we can see as steam. But we can also turn the steam back into water. If we have a spoon, completely dried, if we have a spoon and we hold it over water vapor and we give it a few moments, then you'll see there's liquid, there's water all over the spoon. There's water on it, which means that it turned back from a gas into a liquid. This is known as condensation. So, solids turn into liquids when melting. Liquids turn into solids when freezing. Liquids turn into gases when evaporating, and gases turn into liquids when condensating. Condensation and evaporation are very important because they're part of what we call the water cycle. Have you ever went outside after it rained and noticed a bunch of water puddles everywhere? Well, where did that water come from? Rain, of course. But where do they go? When the sun bakes on these water puddles, then they start heating them up and they start evaporating. All of that water vapor starts climbing up into the sky. And when they're up in the sky, they start cooling down again because it's really, really cold up there. So they condensate, forming clouds. These clouds start packing together and they have more and more and more water until they become so heavy that they make rain. And that rain falls all the way down back, forming those puddles again. And those puddles evaporate again, making one big cycle we know as the water cycle. And it's not just these water puddles either. We get streams, rivers, even oceans. They all contribute to this water cycle by giving a little bit of water for this water vapor that becomes clouds and rain everywhere. And that's how we get water all the way up in the mountains that flow all the way down into the oceans and go all the way back through rain. So today we learned that everything around us is made of matter, and that there are 3 states of matter: solids, liquids, and gases. We also learned that we can change between them by melting, freezing, condensating, and evaporation. I hope you all learned something today. I'm Caitlin from Sci Enza. Bye-bye.